Good day students, and welcome to the class. We thank God for this day and all the blessings which we receive from God every day. Today we shall study Science 1, Chapter 1, Gravitation. We have already studied that a force is necessary to change the speed as well as the direction of the motion of an object. We have also studied the phenomenon of gravitation was discovered by Sir Isaac Newton. He discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? After much thought, he came to the conclusion that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downwards. The force on an apple on the tree is towards the center of the earth, that is, along the perpendicular from the position of the apple to the surface of the earth. The figure also shows the gravitational force between the earth and the moon. Newton thought that if the force of gravitation acts on apples on the tree at different heights from the surface of the earth, can it also act on objects at even greater heights much farther away from the sun, like for example the moon? Can it act on even farther objects like the planets and the sun? Circular motion and centripetal force. Circular motion means the movement of an object along the circumference of a circle or rotation along a circular path. Centripetal force, a force acting on any object moving along a circle and is directed towards the center of the circle, is called the centripetal force. Centripetal means center seeking. That means the object tries to go towards the center of the circle because of this force. We now study the Keplers laws, but before we study the Keplers law, we study about an ellipse. An ellipse is a curve obtained when a cone is cut at an inclined plane. It has two focal points. Focal points are also known as foci. The focal points are the fixed points of an ellipse which are present on the major axis. An ellipse has two axes. The longest axis is called the major axis. It is the longest diameter of an ellipse. Okay, as an ellipse is not a circle, it will not have equal diameters. The length of the diameters will be different. So the longest diameter is taken as the major axis. It is a line segment that runs through the center and both the foci. The sum of the distances to the two focal points from every point on the curve is constant. That is, if F1 and F2 are two focal points of the ellipse and A, B and C are any 3 points on the ellipse, then AF1 plus AF2 is equal to BF1 plus BF2 is equal to CF1 plus CF2. Keplers laws. Planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of the planets' positions were made with naked eyes. By the 16th century, a lot of data were available about planetary positions and motion. Johannes Kepler studied these data. He noticed that the motion of planets follows certain laws. He stated 3 laws describing the planetary motion. These are known as Keplers Laws. Kepler's first law: the orbit of a planet is an ellipse with the sun at one of the foci. That means any planet moves around the sun in an elliptical orbit and the sun is present at one of the foci. Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. Okay, so the straight line AS and CS sweep equal areas in equal intervals of time. That is, if you consider the area ASB and the area CSD, both these areas will be equal. Kepler's third law. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. That is, if r is the average distance of the planet from the sun and t is its period of revolution, then t square is directly proportional to r cube. That means t square upon r cube is equal to constant, where t is the period of revolution of the planet and r is the distance of the planet from the sun. Okay, so we have the three Kepler's laws as: the first law, the orbit of a planet is an ellipse with the sun at one of the foci. Kepler's second law, the line joining the planet and the sun sweeps equal areas in equal intervals of time. And Kepler's third law, the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. Okay, so t square upon r cube is a constant and it is denoted as k. So these are the three laws which Kepler had given. Students, you have to learn all these three laws, the statements, thoroughly from the textbook. Okay, we'll stop here and we'll continue with this chapter in the next video. Thank you.